If you're thinking about studying physics at university, then no doubt you have a huge amount of questions. I've come to the University of Leeds to speak to their admissions team and ask the questions that you need to know the answers to. So what kind of stuff do you look for in a student application when they're maybe writing a bit about some of their experiences?
So we'd love to get to know you on your application, and anything that you list, any activity that you do, list the benefit you got from it and then how you'd apply it onto the physics course.
Okay, so are there any things that you're looking for in particular that students might have carried out when they're doing their A-levels?
Any experience that you do is valuable, and everything that you do is really important, and what you list on your application, we're just trying to get to know you even better.
Okay.
And so just remember the ABCs, which is list the activity you did, the benefit you got from it, and how you'd apply it to the physics course. It doesn't matter if it's a physics related thing or if it's something that you do in your personal life. Maybe you love drawing, or you're in an art club, or you do drama. Anything that you do is applicable to the course, and it helps us get to know you better.
So physics at university, I guess you definitely need to do physics at A-level, and you need to do maths at A-level.
Yes.
Now the question that I think a lot of students have is, do you have to do further maths?
No.
Okay.
Okay. So the third A-level you choose, as you said, you have to do physics and maths to be able to do a physics or engineering degree. We assume that all our students come in with just those two A-levels. So we'll cover any maths content that's higher than A-level maths.
Okay.
So if you've done further maths, then obviously you'll have a bit of an advantage because you'll have seen some of the topics before, but we teach them in a different way, maybe in an applied way, so it won't be exactly the same.
Okay.
But any other A-level that you come will also bring you those skills. So for example, if you've done a chemistry degree, that will help with solid state physics. And even things like English or the humanities, history, the skills you learn at A-level will really help you in your final year project, things like being able to write, analyse text, those sorts of things. So actually your third A-level isn't really important. Do what you're happiest doing.
Okay, yeah, so I think that's something which I was maybe a little bit surprised at. Obviously, when I did A-levels, I did further maths because I really enjoyed it, and so I loved doing it, but I also did chemistry as well. And I definitely think that it is important that students do things which they really enjoy at A-level.
Absolutely. So I had a final year project student this year who'd done English literature A-level, and her writing skills were fantastic. So she'd done maths, physics and English at A-level, and she ended up doing really well on her degree. So please don't worry about, having to do further maths. If you enjoy maths, do it. You will be doing similar topics in your degree, but you don't have to do it in order to succeed on a university degree.
So for the course here, what are the entry requirements, and is there any flexibility in them?
It's difficult to say whether there's going to be any flexibility until the results come through, really, because it all depends on how many applicants we've got, how many actually achieve their grades, and so on. Usually we find that there's a small amount of flexibility on results day, but really it's difficult to say ahead of time. In terms of our entry requirements, it might change in the future. Right now, we're looking for 2 A's and a B at A-level. That must include physics and maths, because physics becomes such a mathematical subject once you get to university. But we're not looking for those A's to be in the physics and maths. We're looking for grades of AAB. We're looking for physics and maths and one other A-level. So there's other routes as well. We've got a thing called Access to Leeds, which is a scheme that we have that encourages people into higher education from all sorts of different backgrounds.
Okay.
If you're eligible for that, then it involves working with us during the summer before you arrive. You submit a couple of assignments, one that's on general study skills, and then one that is physics specific. Exactly what that will be depends on the year, but it'll be some kind of small research project that you write a short report on. And then assuming that all goes well, if you pass that Access to Leeds program, it gives you a 2-grade reduction on the offer. So whereas our standard offer is AAB, if you go through Access to Leeds, it would be BBB.
And do you do a foundation year here for some students?
There are foundation years available, but they actually don't happen in the School of Physics. We have central foundation years that are run by a separate bit of the university called the Lifelong Learning Centre.
Okay.
So if people are looking at coming in that way, then actually those those are the people to talk to about that.
But I guess there's so many options and so many routes through. Probably the best thing to do is just look on the websites and just
Absolutely, yeah.
spend a bit of time researching it.
Yeah, exactly. All the information's on the website in terms of the standard offer, alternative qualifications. If you're not doing A-levels, if you're doing something else like the IB, for example, then obviously there's equivalent offers. It's all listed there on the website, yeah.
So for a typical maybe first year physics student, what does a typical week look like for their course?
So on a physics course during your first year, it's going to be a combination of lectures. So this is more formal teaching with an academic at the front teaching you in a big classroom setting, kind of what you'd expect to do at university.
Yeah.
It's also full of things called workshops or seminars, which is more teaching like you'd experience in school. So you have maybe an academic or a postgrad demonstrator, a smaller group of students, maybe between 20 and 30, and that's where you work through questions together. It's more sort of group learning from each other within a more classroom setting that you're used to in school.
Yeah.
And then you also have personal tutor sessions. So here at Leeds, you have an academic personal tutor and then a small group of about 5 other students in your first year. And the way we run it here is each week you meet your personal tutor group for about an hour and you work through questions together that's related to what you're learning in the course, but it's also a chance to, get to know each other, have a really nice sense of belonging, kind of talk about what's going on if you guys need any help. And then also we have our practical lab sessions. So it's about 4 hours a week, but obviously that can change based on year to year. And that's just where you get to spend your time here in the lab, working with a partner, doing a lab experiment, and getting to refine those experimental skills that you've built on in your A-levels or your previous study.
And is that 5 days a week? Is it like a school week where you're in from 9 o'clock in the morning till 3:30, or does it change?
It changes. So the best thing about university is that it's not just, it can be straight lectures, but you also have like an hour off in between, maybe 2 hours in between lectures or workshops. So it's a lot less structured than school, and it's not, it's as intense, maybe more, but not like the straight 9 to 3:30 like you're used to every day.
So everybody who's going to be doing physics at university will be doing A-level physics or something like that. What are the kind of key topics that you think can really kind of help with the understanding and kind of really prepare students for university?
Well, first of all, as well as doing A-level physics, they'll also be doing A-level maths, because anywhere is going to ask for that as well.
Yeah.
A good understanding, a solid understanding of all the different topics is certainly going to help. But if you wanted to pick out certain topics that are going to be most beneficial, then I'd say the mechanics from physics, but also the idea of fields and energy. Those are really key topics. And then in terms of the maths content from the maths A-level or equivalent, a good understanding of the stuff that's covered on vectors would be really helpful. But the main thing I'd say is really good understanding of calculus and being able to apply calculus, differentiation, integration.
Because I think that's something which isn't really covered much on the A-level physics course.
Absolutely, yeah. So this is precisely the reason why for physics at university we ask for that A-level in maths as well.
Yeah.
Because it becomes such a mathematical subject at university, we've got to have that background maths knowledge. So build on as well.
So differentiation, integration, they're the kind of things that students really need to start to become familiar with?
Absolutely, because those are the tools that we're going to use to model physical phenomena once they get to university.
So with the course, it's going to be probably a little bit more challenging at times than some of the material that students will have covered at A-level. What kind of support is there for students who maybe need that bit more help?
There's so much support, and the number one place to go to support is the academic or the lecturer who's teaching you.
Okay.
So often people don't get in touch with them or send them emails or ask them questions. They're the best person to ask if you're struggling on a certain module. They obviously know the answer, and they love helping people when they have questions. And so all of the time, university students don't ask questions.
But I guess that's like at school where students won't even ask the teacher for help.
Exactly, yeah. So that's definitely the first place to start. The next place would be your peers. So here at Leeds, we have something called peer-assisted learning, so PAL groups. So in your first year, your tutor group, a few tutor groups come together and they're mentored by second or third year students.
Okay.
And so that's another peer learning group where you come together and ask questions and learn from each other. There's also lots of support from the library. So the library is a great place to ask for help. Here at Leeds, we have dedicated math support. So if you're struggling with a certain math topic, you can go to the library during their drop-in hours, and it's like one-to-one tutoring for free. It's amazing.
Oh, wow.
And then obviously you can go online to Physics Online and also review your A-level stuff as well.
Yeah.
But there's lots of support and lots of places to ask for help. And so if you do have a question or you need help, there's always someone that you can go to.
And going back to the library, I guess there's a lot of books there. Do students have to buy a full set of books before they start the course, or is it better to wait or is there stuff they can access online like journals and so on? How does that work in terms of buying the textbooks that they need for the course?
Yeah, so no textbook, you don't have to buy any textbooks. Any textbooks that we have would be you can get for free from the library as a student. And then a lot of the textbooks too are available online in just a PDF copy anyway from the library. So you log in using your student ID, and then you get access to the online textbook that you can, textbooks are great, but you can't search through a textbook easily. So you can always use the PDF online and search through it as well. So that's how I navigate through textbooks and to help me to find the topic that I'm looking for.
So you don't need to spend hundreds and hundreds of pounds on books that you might not even use if it's all there.
Exactly. And if you are asked to buy a book, check to see if it's available in the library first, because there are usually definitely a few copies in there that you can use as well.
So after a student has finished the course, what can they expect after they graduate?
That's quite a difficult question to answer, really, because physics is a subject that really keeps your options very open, very broad. Because of the kinds of skills you get from a physics degree, things like mathematical modelling, coding, there's a lot of different kind of employment sectors that are looking for physics graduates. So there's routes into engineering, for example, particularly things like mechanical engineering, aerospace engineering. There's routes into things like medical physics, things like radiography. And then those are kind of maybe the things that a lot of people see as quite obvious routes for a physics graduate. But then there's lots of things as well that people are less likely to think of. So because of those coding skills, there's a lot of physics graduates going into computer science and coding. Because of the modelling skills, again, combined with those coding skills, there's a lot of people at the moment going into things like financial technology, fintech. And then some of the other areas that I know people have gone into, a couple of my previous tutees have gone into the RAF as pilots or technicians for the aerospace sector.
But pretty much everybody who leaves gets a job if they want a job.
Absolutely. It's a very employable degree. So if you look at the statistics on it, in terms of how the proportions of graduates finding employment, then and physics does very well on that. But also, again, if you look at the stats on this, there's a higher proportion of physics graduates going into further study than really for any other subject.
Okay.
So things like, research degrees, PhDs, also PGCEs, teaching certificates, things like that.
So we're filming the video at the University of Leeds today. What in particular really stands out about the physics course that you have here?
So I would say our physics course is incredibly flexible. At the end of the day, your physics degree is your own, and no two physics degrees are going to look the same. The courses you take, your optional modules, if you do a study abroad year or you're in industry, the societies you join, the clubs you join, all of that is unique to your own degree. Here at Leeds, the first 2 years are the same for both a bachelor's course and a master's course. And at the end of your 2 years, you can decide if you want to stay for the full 4 years and get an MPhys at the end, or you want to do just a Bachelor of Physics degree. So it's really flexible, and you get a lot of choice in your degree as well in terms of if you want to study the straight physics degree, if you want to do astrophysics or theoretical physics. You can make the choice when you apply, but if you're deciding, okay, I'm not really loving astro, I just want to do straight physics, you can switch on to that course. It's meant to be really flexible, and we understand that we're asking you to make a really big decision at the start of when you apply to university, and you may not have all the information you need to make the right choice for you. So we try to introduce those choice points at the time when the time is right.
Okay, and you mentioned about a bachelor's or a master's. Could you explain really the difference between those two?
Yes, so a bachelor's degree is the first degree. So a BSc is what we have here, so a Bachelor's of Science. And then a master's degree is an integrated master's where you get both a bachelor's degree and a master's degree. The BSc is 3 years, the master's is 4 years. And so it's a continuous degree where you get a master's degree at the end of it.
And when people are applying for university, do they know which one they're applying for at the start, or is it something that they kind of decide maybe after that first or second year about how they're getting on at uni and what they enjoy?
Yeah, so that's why I was trying to say our degrees are really flexible, because yes, when you do apply, you either apply for the bachelor's or the master's. Here at Leeds, our entry requirements are the same for both bachelor's and master's.
Okay.
And the reason that they're the same is because we understand that you're going to do the first 2 years the same as everyone else, no matter what you're doing. And then at the end of those 2 years is when you decide if you want to do a bachelor's or a master's. If you do want to continue the master's, there are like grade requirements that you have to meet. So as long as you're meeting the minimum grade threshold, then you can continue on for a master's.
Something I've been really impressed with is actually at Leeds, this building that we're in at the moment. I mean, it seems pretty new and kind of cutting edge. So do you want to say a few bits about where we are in this department?
Yep, so we are in the School of Physics and Astronomy. This is the William Henry Bragg building. It was just opened a few years ago. We're really excited because it's brand new, it's wonderful. We have fantastic teaching facilities. So this is our undergraduate physics labs. We have great independent study areas, group study areas that you can book yourself. We have our physics study zone. We've got great computer clusters all over the building and all over the campus, and some great lecture theaters too, and a great cafe, obviously, because that's what you need, and some great group study areas downstairs. And so basically, when it's term time and we have lots of students here, you can just find everyone downstairs having a coffee, doing some work, meeting up with friends. It's a great place to work, and I feel really lucky to be in this building.
Yeah, it looks absolutely amazing. So what might students do? Maybe they finished their A-levels. What would your advice be to help them sort of prepare for university, so when they come into those first couple of weeks of university, they're not completely overwhelmed by it all? Is there anything that students can do?
Absolutely, yeah. I think the most important thing you can do is practice problems.
Okay.
So you can look back over your notes and you can revise some of the content by all means, but that's actually far less important than being able to apply that knowledge and solve problems. Because that problem solving is really, I think, the most important skill that comes out of a physics degree.
Yeah.
And so we're going to be doing lots of that during the degree program. So if you can get some practice of that before you arrive, fantastic.
I know lots of students might have been using Isaac Physics, or they probably should have been using Isaac Physics while they did A-level physics. Is that something that you'd recommend, or?
Absolutely, yeah. So Isaac Physics, the problems on Isaac Physics range in difficulty. They go all the way up to stuff that's suitable for university. So actually, one of the things that I do before our students arrive is to send them some recommended problems for Isaac Physics, and give them, some guidance on how to log in if they haven't used it before.
Yeah.
Because it's got so many useful problems on there, and just that reminder of how to tackle a problem and how to approach it before you arrive is really important. Because as well, it's amazing how much you forget during the 6 weeks before you start university.
That's right, yeah. And I guess if they did their exams maybe in kind of June time, it might be 3 or 4 months really between that and actually coming to university sort of later in September. So what would you say to somebody who's maybe unsure about which course to do at university? Maybe they're thinking maybe between engineering or physics. What would be maybe your argument for studying physics?
I think I'd argue for physics in that case, because if they're torn between these different subjects, the chances are the bits of the subjects that they like are physics.
Okay.
If they're certain that they want to go into engineering, for example, then they'll enjoy all of the different things that are covered in an engineering degree. Yeah. But if they're torn between those two subjects, that's probably because they actually really like the physics content and the physics bits of what would be covered in an engineering degree. But I think you can make the same argument as well for if they're torn between, say, something like theoretical physics and maths.
Yeah.
Chances are the reason that they're torn is because the bits of maths that they enjoy are exactly the bits that are going to be used in theoretical physics.
Mm-hmm. And of course, I suppose with the course itself, it's not that everybody does the same physics modules for the whole 3 or 4 years that they're at university. So they can pick and choose and sort of, I guess, mould the degree to what they really enjoy.
Yeah, absolutely. So what you'll tend to find everywhere really, is that for the first couple of years of the degree, it's quite structured, and everyone will be doing fairly similar stuff with a little bit of, you know, optional material here and there.
Yeah.
But then in the higher years, so the final year of a BSc and then the final 2 years of an MPhys, then there's a lot more scope for picking and choosing the areas and the topics that you enjoy most.
So what is the role of a personal tutor at university?
So every student will be assigned a personal tutor in their first year, and that will be the same person who follows them all the way through to the end of their degree course. Mm-hmm. And it's the person who will offer support and guidance for things to do with the physics degree. So, you know, what sort of project should I do and so on. Okay. But we're also there to, we can point you in the direction if you need any further support. So we're not trained counsellors, but we can advise you on people to go to if you're having any trouble outside of your degree course. And we also have student support officers in the school who are there to support students who are struggling a bit with various aspects. Mm-hmm. So in your first year, you will meet your tutor every week and you'll go through physics problems, because I think we all know it's really important to deal with those practice problems. And then in second year, you'll meet your personal tutor 3 times a year, and that will follow on to third and fourth year. So we keep in contact with our students throughout the degree course and beyond. So your personal tutor might be the person you ask for a reference when you apply for jobs and things like that.
So the personal tutor is the academic support, but I guess there's always going to be that support within university for any other issues that students might have, if it's financial or well-being and health and things. And that support is always there, isn't it?
Absolutely. So as I was saying, as a personal tutor, we'd be able to point you in the right direction for those support, but we have a student counselling service, we have financial services and so on that can sort of help students throughout any issues they might be facing. So the most important thing I'd say is don't ever struggle in silence. If you're worried about something, however small it is, go and see your personal tutor and they would be able to point you in the right direction of who to get proper support.
Okay. So physics can be a practical subject. I know that people doing A-level will be doing various practicals that they have to complete. What's the lab work like at university?
So here in Leeds, what we do is the lab work is there to build your lab skills rather to reinforce theory. So at A-level, you might be quite used to your teacher telling you some theory, and then you do a little practical that reinforces what you've just learnt and proves that your teacher was right. Whereas here, what we do is we're teaching you those skills that you'd need to be an experimental physicist. So how to keep a working notebook, how to analyse your results, error analysis or uncertainty analysis is a really big thing. Mm-hmm. And it's those skills that are important rather than the theory underpinning the work that you do. Yeah. So in Leeds, our first year experiments are all sort of based on A-level topics. So you don't need to have done the degree level content in order to do the experiments. So first year you come into lab 1 morning a week from 9 till 1, and you do a series of experiments and begin to build those skills up. We know that not everybody has access to the same equipment at schools. So we do some introductory experiments to start you all off at the same point. So that you shouldn't feel worried about coming and doing practical work. Now, unfortunately, we make our theorists do experimental work.
Okay, so if we want to be a theoretical physicist, they're not just going to be sat in a classroom doing math, they're going to be in the lab as well.
No. So part of the Institute of Physics accreditation is that every physics student should do some experimental work. Mm-hmm. And it's also really important for theorists to know how experimental physics works, because if you're developing your new theory, you need to know how the experimental is going to test it, you know, what the bounds of possibility, what the uncertainty are in your results. So so every first year student does experimental physics. In the second year, the theory students then do a communications style module at Leeds rather than physics, but the physicists and astrophysicists will go on and do lab work similar to first year, but obviously more complex experiments, and they'll be in the lab for a whole day rather than just a morning.
And for those doing the kind of astrophysics, do you have telescopes here?
Yes, we're really lucky. We've got 2 telescopes on the roof. We do a lot of solar physics here, so they look looking at sunspots and things like that. So the astro students will be assigned a telescope time as part of their degree course. In second year, we also have some experiments that are tailored towards the astrophysicists. So current astrophysics research depends on sort of analysing big data sets. So they'll do some sort of these big data analysis. So, looking to see if they can analyse planets and things like that.
Now, of course, you don't know what you don't know. For the students, what support might be available for them that they didn't know was on offer at a university?
So the first support when you're entering is scholarships. So there's going to be scholarships for both UK students and international students. So check them out. Financial support is available to you, that's number one. And number two, while you're on the degree program, the employability services team, so the employability team or the career service team, they are your guardian angels. What they're going to do is help you find a job anytime throughout your degree. They'll help you with CV, interview practices. There's going to be loads of job opportunities that they advertise. So like to work while on your course, to work in the summertime, to do your year in industry placement, and then also to help you find that graduate career at the end of your degree. They are the best team in the world, so take advantage of them because they're not going to exist when you leave the university. And so they're kind of like your life coach as you go through your degree.
So you've got support financially,
yeah,
and then also, which is quite important, you need a job at the end of it to keep earning money. So there is support at university for that. Yeah,
and they're great. And there's also going to be lots of jobs that are advertised just for your specific institution, whether they're local jobs or graduate sort of employment opportunities or even year in industry. So it's kind of like there's going to be a job listing for you and they'll help you get that job if you access their support.
Now, something that students might not have covered in their A-levels is coding. And is that something that they have to know before they come to university, or do they get taught it when they come here?
It's very much like sort of further maths. You don't have to have done any coding here in order to succeed. So we teach you coding in the first year, and we assume that people haven't done any coding before. So if you've done a bit of coding in your spare time, or you've done a computer science A-level, then obviously that will be the place where you've got that slight advantage. But we're assuming people don't know anything. The coding language we use here is Python. Which is quite a nice, friendly starter code to use. And once you've learned how to code in one language, it's often easier to learn how to code in subsequent languages. But unfortunately, you can't do physics now without learning how to code, whether it's coding some equipment you're going to use or writing code to analyse your data. It's part and parcel of being a physicist these days. So you will do coding, but we'll start you from scratch.
So for students who haven't done any coding beforehand and they maybe want to find out a little bit more, maybe before they start a physics degree, where can they go to find some online support?
So there'll be lots of online resources available, especially for things like Python. So University of Leeds, we have the Future Learn course, which is lots of MOOCs that are free and online. And they've written an introduction to coding module, which they've done with the Institute of Coding. So that might be a good place to sort of start having a look at different coding.
So with all the experiments that students might carry out in the lab, what's one of your personal favourites? What's the kind of thing that makes students really go wow, or just, really gives them that sense of wonder?
Oh my goodness, so that's a really hard question for me to answer because I'm an experimentalist by heart. I love being in the lab. So in Leeds, we've got things like you can recreate Millikan's oil drop experiment, which I think is quite exciting when you learn about some theory or some famous experiment, and then you get to recreate it.
And I think that's something that students probably very rarely see in their classroom at school, but they might have heard about.
Yeah, we've got lots of sort of fancy equipment here. So you might have learned about the charge to mass ratio using a fine beam tube. So we do that in our first year as well. You get to do Bragg diffraction in the Bragg building, and I was ridiculously giddy when I first had to teach Bragg diffraction in this building.
Okay, so Bragg, so going a bit of a deep dive into the physics. So this is something that students might not be aware of, but what is Bragg diffraction and who is it named after?
So Bragg diffraction is named after Sir William Henry Bragg, and he was based at Leeds when he did some experiments looking at X-ray diffraction. So we know that electromagnetic waves diffract when they're going through a gap that's of the same order of magnitude as their wavelength.
Yeah.
So X-rays, it so happens that the spacing in crystals is about the order of magnitude of a X-ray wavelength. So if you shine X-rays on a crystal, then you get diffraction effects. And by measuring the peaks, the reinforced waves, you can find the spacing between two crystals. And this was really fundamental. It's allowed the structure of different molecules to be found and allowed DNA structure to be found. So we're very proud that in Leeds, William Bragg did his work here. And so you can recreate that experiment in the Bragg building? Yes. So we do one in the first year and a slightly more technical version in the second year. Yeah.
And so for students doing their final year project, what kind of things might they become involved with?
So we have lots of active research groups here. So final year students will work with academics and PhD students in a research active group and hopefully do publishable work. So it might be that you get to use the big X-ray diffraction machines in the proper research labs, or you might get to analyse some astrophysical data that can then go forward into being published work. So everything you do in the first, second and third year, if you're an MPhil student, is leading up to giving you those skills to be a proper experimental physicist or theoretical physicist, and to be able to produce work at the level of a proper research scientist.
And of course, I suppose some students continue that work. They want to take it further, don't they, with PhDs or other study?
Absolutely. So at Leeds, you can stay on and do a Master of Science if you've chosen to do the BSc route. Or you can apply to do a PhD. So a PhD is you're assigned to a research group and you spend 3 or 4 years on a specific project, and will get publishable data from that, it can be a very exciting thing to do.
Yeah. So university, it's a big decision for students, especially if they're maybe leaving home and going somewhere, a couple of hours or maybe even further away from where they've maybe lived for the whole life. What would you say to somebody who's maybe unsure about where to study?
So this is a really good question. When you apply to university, it feels like the biggest decision that you're making in your entire life. And the most important thing to remember is that for a physics degree especially, you're going to be studying at an accredited institution. So your physics degree is going to look the same pretty much wherever you study for those first 2 years.
Okay.
Accreditation means that the Institute of Physics has done quality assurance on the degree that you're getting and says, yep, they're teaching the right things. This is a physics course. So no matter where you study, for those first 2 years, it's all going to be the same sort of content.
Yeah.
The most important thing I think is that you have a sense of belonging where you are, and that's going to be different for everyone. If you can visit the campus where you're going to study, that's great because you kind of get a feel for the vibe on the day, and that's really important. There's also different types of campuses as well, so it really depends on what you like. So the University of Leeds is a campus-based university set within a city, which is great because you kind of have the best of both worlds. So it's like, we're all together on this campus, but it's a short walk to the city and like vibrant nightlife and like museums and galleries and all of those sorts of things. And then there's other types of universities that are just city center universities. So their buildings are kind of set in different buildings across the city. So not really a campus, but kind of a campus, but in lots of different buildings across the city. And then there's also campus-based universities, so just campus-based, which is the campus is set outside of the city center. So a little bit more remote, so you're not kind of linked into that city center vibe. So that's why I think Leeds is obviously the best of both worlds, but that's biased because this is what I really like. But again, it's dependent on what you want. So wherever you go to study, you're going to have a nice time. You're going to meet people just like you. You're going to make friends. But it really depends on what type of vibe you want on campus, and also what your preferred way of life is. If you want to be outside of the city center, inside the city center, it's really up to you.
And I guess the best way to experience that is actually to try and get to the university itself. So not just looking at things online, but actually trying to visit the city, having a look around the campus or the university and seeing how it feels. Yeah,
and I think just trust your intuition. When you go there, you're going to get that special feeling and you're like, you know what, this is where I want to go. So really trust that instinct and know that it's personal for you. It may not be personal. It's not a decision that the key people in your life are making. So you're the one who's going to have to be studying at the university, not your friends, not your parents, not your different family members. So it's up to you, and you have the power to make that decision yourself. And it's important to go with your gut.